I'm going to start section 7.3. In this section, we're going to be looking at solving trig equations, and I thought I'd just show you a bunch of examples where we're solving equations here. In the first example, I want to find all the solutions to 1 minus cosine theta equal 1/2. Okay, if I add cosine theta to both sides and subtract 1/2, then cosine theta equals 1/2. Now cosine of theta is equal to adjacent over hypotenuse. So when I set up my triangle here, the adjacent side is 1, the hypotenuse is 2, and the opposite side would be root 3. This is one of our common triangles. This is working with a 60-degree angle, or pi over 3 using radian measure. Now, if I were to flip the triangle upside down into quadrant 4, the adjacent side is 1 still, the hypotenuse is 2, the opposite side is negative root 3, which I don't care about for cosine theta, since cosine theta is adjacent over hypotenuse, but that angle that we'd be talking about here would be 5 pi over 3. So cosine of 5 pi over 3 would also be 1/2. Now if I were to flip this triangle into quadrant 2 or over here into quadrant 3, then that will affect the adjacent side. The adjacent side will be a -1, and so I'm not going to want to look at any angles that are in quadrant 2 or quadrant 3, therefore. Okay, now another thing is that remember that all the trig functions are periodic. The periodic factor of cosine theta is 2 pi radians. So if I were at the radial line pi over 3 and I were to go 2 pi radians beyond that, that would put me right back to my start point here, and I'd be using an angle of 7 pi over 3. Okay, 7 pi over 3 would produce the same 30, 60, 90 right triangle, and so cosine of 7 pi over 3 would also be 1/2. If I were starting at 5 pi over 3 and I were to go 2 pi radians beyond that, that would bring me right back to my start point, and I would be using the radial line 11 pi over 3. Okay, it'd produce the same triangle there, so cosine of 11 pi over 3 would also be 1/2. Now really there's infinitely many solutions to this problem, since I can use the periodic factor infinitely many times to produce either one of these two triangles. And so really anything that would be of the form pi over 3 plus increments of 2 pi, or 5 pi over 3 plus increments of 2 pi, k is an integer here, is going to be a solution. Okay, and of course k being an integer could mean that k is negative, so I could be rotating around the center clockwise rather than counterclockwise. Okay, now most of the time when you're working with trig equations, if there's no conditions on the variable, there's going to be infinitely many solutions. So to avoid situations where every single problem is going to be infinitely many solutions, we're going to have some conditions on theta that we're going to want to be aware of. In most of the problems, we're going to want to say that let's just find all the solutions on the interval 0 to 2 pi. Okay, so if we're only on the interval 0 to 2 pi, I would only have two solutions to this equation here, 1 minus cosine theta equal 1/2. That would be where theta is pi over 3 and theta is 5 pi over 3. Okay. All right, so unless we're told otherwise, we're gonna continue to solve equations, but we'll assume that theta is going to be an angle between 0 and 2 pi here when we give our answers. Anything outside of those boundaries we're going to disregard. So here's another example. Suppose I want to solve the equation 4 cosine squared theta minus 3 equals 0. Well, if I add 3 and divide by 4, then cosine squared theta, that's the same as cosine theta, the quantity squared. And so to get rid of the power of 2, I'll want to take the square root of both sides. That way cosine theta will be all alone. Of course, when you take the square root of both sides, don't forget about the plus or minus there. Square root of 4 is 2, right? So I'm going to have plus or minus root 3 over 2 on the right. Now, cosine of an angle, again, is adjacent over hypotenuse. So if the adjacent side is root 3 and the hypotenuse is 2, one angle that we would be using would be pi over 6 radians. Okay, that'd be a 30-degree angle using this 30, 60, 90 right triangle. And if I were to flip that triangle into quadrant 4, that won't affect the adjacent side or the hypotenuse. It'll affect the opposite side, which I don't care about for cosine theta. So cosine of 11 pi over 6 would also be root 3 over 2. Now how about what if cosine theta is equal to negative root 3 over 2? Well, if the adjacent side is negative root 3, then you're going to be to the left of the center there, and the hypotenuse is 2, the opposite side would be 1 then, and here would be another angle that we could use. Cosine of 5 pi over 6 would be negative root 3 over 2. And if we were to flip this triangle into quadrant 3, that would affect the opposite side, which we don't care about for cosine theta, right? Because cosine theta is adjacent over hypotenuse. And that would still be negative root 3 over 2. This angle here would be 7 pi over 6. So cosine of 7 pi over 6 would also be negative root 3 over 2. Okay, these four angles are going to be my solutions. These are all in the interval 0 to 2 pi. And any increment beyond these four is going to be producing an angle that is outside the interval here that we are working on. Okay, here's another example. 5 cosecant theta minus 3 equal 2. If you add 3 and divide by 5, then cosecant theta equals 1. Cosecant theta is defined to be the reciprocal of sine theta. Okay, so 1 over sine theta, that's the same as cosecant theta. And in this form here, if I multiply both sides by sine theta equal 1. Okay, well sine of pi over 2 is 1. And so that would be my one and only solution on the interval 0 to 2 pi. Okay, here's another one here. The square root of 3 times cotangent theta plus 1 equals 0. If you subtract 1 and divide by root 3, we want to solve cotangent theta equal negative 1 over root 3. So tangent theta is opposite over adjacent. Cotangent theta would be the reciprocal of that, adjacent over opposite. The adjacent side is negative 1. The opposite side is root 3. That's going to mean that the hypotenuse would be 2. So we've got a 30, 60, 90 right triangle, but we're in quadrant 2. The angle that we'd be talking about there would be 2 pi over 3. Also, negative 1 over root 3, that's the same as 1 over negative root 3, right? So if the adjacent side is 1 and the opposite side is negative root 3, then that's going to put me into quadrant 4. The hypotenuse would be 2, and the angle that we'd be talking about there would be 5 pi over 3. And I'm still working with a 30, 60, 90 right triangle, of course. So cotangent of 5 pi over 3 would also be negative 1 over root 3. Okay, both these numbers would be answers. If I were to have anything in quadrant 1, then I would have positive values in the numerator and denominator. I don't want that. Also in quadrant 3, the opposite and adjacent sides are both going to be negative, but negative over negative is positive, and I don't want that in this problem since I've got a negative number there on the right. Okay, here's another example. Suppose that we want to solve sine of 2 theta equal 1/2. Okay, well, I know that sine of pi over 6 would be 1/2, since I'd be working with a 30, 60, 90 right triangle. The opposite side is 1, the hypotenuse is 2. The adjacent side then would be root 3. Now, here's the thing. I don't have sine theta equal 1/2. I got sine of 2 theta equal 1/2. So this angle here, I don't want to be calling theta. It's going to be 2 theta. 2 theta equal pi over 6 means that theta would be pi over 12. And so that's going to be one answer. Now, if I were to flip this triangle over into quadrant 2, that's going to affect the adjacent side, which I don't care about for sine of an angle. If I had sine of 5 pi over 6, that would also be 1/2. Okay, because the opposite side is 1, the hypotenuse is 2. But again, I don't have sine of theta equal 1/2. I got sine of 2 theta equal 1/2. So this angle here, I want to be calling 2 theta. 2 theta would be equal to 5 pi over 6. If you divide by 2 on both sides, then theta would be 5 pi over 12. All right, so these two numbers are going to be solutions. These are not the only solutions, though, okay, because we have to use the periodic factor to see if there's any more solutions. Now, how I got pi over 12 was I took 2 pi equals pi over 6 and I divided both sides by 2. But remember that the sine function is a periodic function of period 2 pi, so I'd want to add increments of 2 pi. Basically anything of the form pi over 6 plus 2 pi times k, where k is an integer, is also going to be a solution if we're on the interval 0 to 2 pi. Divide both sides by 2, so that way theta is all alone. And you'll have theta equal pi over 12 plus, the 2's will cancel there, pi times k. Do the same thing with this other equation here. We said that 5 pi over 6 is going to be a value for 2 theta, not theta, because I've got a double angle here. And the sine function is periodic. The periodic factor is 2 pi radians, so any increment of 2 pi would also possibly produce a solution if we're on the interval 0 to 2 pi there. And divide both sides by 2. Okay, so theta would be 5 pi over 12 plus pi times k. Now k is an integer, so at this point I'd want to be selecting some k values and just check and see if I'm on the interval 0 to 2 pi. Well, if k is 0, we get pi over 12 and 5 pi over 12. That's what we had already when we drew our triangles and divided by 2 on both sides there to get theta all alone. If k is 1, pi over 12 plus pi would be 13 pi over 12, and yeah, that's going to be on the interval 0 to 2 pi, so that would also be a solution. If theta is 1 here, 5 pi over 12 plus pi is the same as 12 pi over 12. So 5 pi over 12 plus 12 pi over 12, that would be 17 pi over 12, and that would also be on the interval 0 to 2 pi. If k is 2, pi over 12 plus 2 pi, 2 pi is the same as 24 pi over 12. If you add pi over 12 to that, you'll get 25 pi over 12. That is bigger than 2 pi, so I don't want to include that number. And if k is 2 here, 5 pi over 12 plus 2 pi, 2 pi again is the same as 24 pi over 12, plus 5 pi over 12, that would give me 29 pi over 12. Both of these numbers are now outside of the interval that I'm working on, so I would disregard those. Anything bigger than 2, would also mean that I'm going to be getting values of theta that are bigger than 2 pi. Okay, so in this problem it looks like I'm going to have 4 solutions. Pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Now, of course, in a problem like this, using the periodic factor is important. If I didn't do that, I would only have 2 out of the 4 numbers, which of course is incomplete and therefore wrong. So in these problems here, when the angle is not just theta, make sure that you're using the periodic factor, okay, so that you've got all the solutions on the interval 0 to 2 pi. We'll do one more here in this video. So here's another example. Suppose I want to solve tangent of theta over 2 equal root 3. Well, tangent of theta is opposite over adjacent, right? So the opposite side is root 3, the adjacent side is 1. The hypotenuse then would be 2. So I'm working with a 60-degree angle. I've got a 30, 60, 90 right triangle. Now I don't have tangent theta, I've got tangent of theta over 2. So this angle, theta over 2, would be equal to the angle pi over 3. If you multiply both sides by 2, then theta would be equal to 2 pi over 3. Okay, that's going to be one answer. Now, negative over negative is positive. So if I had negative root 3 over negative 1, a tangent of an angle is opposite over adjacent. So the opposite side is negative root 3, the adjacent side is negative 1. Again, negative over negative is positive, you'd still get root 3 there. Hypotenuse would be 2, and the angle that you'd be referring to there would be 4 pi over 3. Okay, now I don't have tan theta, I got tan of theta over 2, so theta over 2 would be equal to 4 pi over 3. If you multiply both sides by 2, you're going to get 8 pi over 3. 8 pi over 3 is bigger than 2 pi, so I wouldn't want to include that number here in my answer. Okay, and really anything of the form theta over 2 equal pi over 3 plus increments of pi. Remember that the tangent function is a periodic function, but the periodic factor is pi radians. So I'd want to add increments of pi to pi over 3, also add increments of pi to 4 pi over 3. If you multiply both sides of these equations by 2, then theta would be all alone. And so here's kind of the general form that we want to be using. And I want to be selecting some values of k now. So if k is 0, 2 pi over 3 plus 0 is 2 pi over 3. We've already said 2 pi over 3 is one answer. If k is 0 here, you're going to have theta equal 8 pi over 3. 8 pi over 3 is bigger than 2 pi, so I don't want to include that one in my answer. If k is 1, then you got 2 pi over 3 plus 2 pi. 2 pi is the same as 6 pi over 3. You're going to have 8 pi over 3. When you add those, we've already said 8 pi over 3 is not a solution because you're outside of the interval now. Down here, 8 pi over 3 plus 2 pi. Well, you're already bigger than 2 pi if you're adding 2 pi to 8 pi over 3. You get 14 pi over 3, and of course that's bigger than 2 pi. So you're going to disregard really anything now that is greater than or equal to 1 for the k value. Okay, the only solution here would be where theta is equal to 2 pi over 3. Okay.